All right, so today we're going to do a quick review of exponents since we haven't done it in a while. So there's 4 main exponent properties we're going to review. First of all, there's multiplying with exponents. So when we have the same base, so here my base is 2, the big number. When I have the same base, all I need to do is add the exponents. So 2 to the third times 2 to the second is equal to 2 to the fifth. I added 3 plus 2 and got 5. With dividing with exponents, I'm basically doing the opposite. So I subtract the exponents. Again, it has to have the same base, and I keep the base. So 2 to the fifth divided by 2 to the second, I subtract 5 minus 2 and get 2 to the third power in simplified form. Then we have raising a power to a power. So I have 2 to the third, and then I'm going to take that and raise it to the second power. So I have those exponents touching right there. I'm going to multiply the exponents and again keep the same base. So 2 to the third, raise that to the second power, 3 times 2, and that gives me 2 to the sixth power. And then lastly, and the hardest one, is negative exponents. So when we have a negative exponent, it can be expressed as a positive exponent in the denominator of a fraction where the numerator is 1. So 3 to the negative second is the same thing as 1 over 3 to the positive second. If you are confused or don't understand this as much, go back to the negative exponent video and watch how we get this and why those two things are equivalent to each other. Why a negative exponent is expressed as a positive exponent in the denominator, and that 1 is our numerator. Okay, what is the value of the expression 5 to the second raised to the sixth power divided by 5 to the third power raised to the third power? So the first thing we want to do when we have a division problem that's written horizontally, rewrite it vertically, and that helps us understand it better. So 5 to the second raised to the sixth power divided by 5 to the third power and raise that to the third power. So make sure that you are writing everything down on your paper. Okay, so there's two things I see. I see power to power here, and I see division. So I can simplify both the numerator and denominator. So before I start to divide, I'm going to do that first. Again, this power to power we just reviewed. When we have that, we need to multiply the exponents. My base stays the same, 5, and I do 2 times 6, which I get 12. The bottom, power to power again, so 3 times 3, so I get 5 to the 9th power. Now I have the same base of 5, so I can use my exponent rule. When I divide, I keep my base, so 5. I subtract my exponents, 12 minus 9, and I get 3. But when I go back to the question, it's asking me to find the value. It doesn't ask me to simplify. So when it asks me to find the value, I need to actually multiply the answer out, which means I need to do 5 times 5 times 5. 5 times 5 is 25 times 5, which is going to be 125. And remember, all of the stuff with exponents are usually all on the calculator inactive. So we want to really practice this with no calculator. All right, so this question again is asking for the value of the expression. I see all like bases of 6, but this time I see 3 different things. I see multiplication, I see a power to a power, and I see division. So what I do see in the numerator is that I can start simplifying things. So my first thing I need to take care of is this power to power. So I'm going to bring down everything else. This 6 to the 5th, I'll deal with that in a second, times, again, I'm going to multiply 3 times -1. So this is going to become 6 to the negative third power, because a positive times a negative is a negative. And then I get 6 to the second power still in the denominator. So before I start to simplify, I see that I have a negative exponent. So I need to bring that down and make it a positive exponent by bringing it to the denominator. So that means in the numerator, I'm just left with 6 to the 5th. I still have 6 to the second power in the denominator. And now I'm going to multiply that by 6 to the positive third. Remember, we never move our positive exponents. The reason we don't have a 1 in the numerator, like we reviewed with our exponent rule, is because I already had something in the numerator. 6 to the 5th stays there. So now I see that I can simplify my denominator because I have like bases. So 6 to the 5th power is going to stay in the numerator. 6 to the second, if I'm multiplying, I'm going to add my exponents, 2 plus 3, and I get 6 to the 5th. I need to find the value, so I'm still going to I need to use my division property. When I divide with like bases, keep your base, subtract your exponents. 5 minus 5 is 0. And this is a review. If you remember, anything to the 0 power is 1. If you don't remember why that is, go back to the video on dividing exponents, and it goes through why anything to the 0 power is 1. Okay, so this question just asked you to simplify. So that means I don't need to multiply it out. My answer should still have exponents. The other big thing I see here is that I have different bases. I have a base of 3 and a base of 4. Remember, if I have different bases, I cannot combine your bases or your exponents. It's like combining like terms. So the numerator and the denominator, I don't see anything I can combine because the numerator has a base of 3 and 4, I can't combine them. The denominator has a base of, again, 3 and 4, can't combine. But one thing I do see in the denominator is I just have this 3. So remember, anytime I have just a number, what's really there is an invisible exponent of 1. So go ahead and make sure you've got all this written down. And make sure you add that 1 there so you don't forget that there really is an exponent. So since I can't simplify, I'm going to go ahead and use my division exponent rules with my like bases. So let's do 3 to the 8th and 3 to the 1st. I'm going to subtract my exponents, 8 minus 1, and I get 3 to the 7th. So it's super important you put your 1 there so you don't just leave it as 3 to the 8th. I do need to subtract this 1 down here. Times my 4s, 4 to the 5th, 4 to the 2nd, keep my base, subtract my exponents. 5 minus 2 is 3. I can't go any further. I can't simplify. They're not like bases. I have to leave it as is, and it's just asking me to simplify. So this is my final answer. Just know that if I were to write it like this, that would also be correct. Because multiplying, it doesn't matter the order, that's still going to be the same thing. Okay, take a minute and write this down. So I see lots of stuff. I see power to power, multiplying, dividing, negatives, and different bases. Putting it all together, our hardest one. So the first thing I need to take care of is this power to power right here. So I'm going to multiply my exponents. It's going to be 9 to the 2 times negative 3 is negative 6. Bring down everything else. Next thing I need to take care of are my negative exponents. So I have 1 in the numerator and 1 in the denominator. So let's rewrite everything I'm not moving, which are all my positives. So 9 to the 4th, 5 to the 2nd stay in the numerator. I need to move the 9 to the negative 6th down to the denominator. And remember, it's just the opposite. If I have a negative in the denominator, I need to move it up to the numerator. and it'll become positive. So again, a negative exponent, when you move it to the opposite side of your fraction bar, it becomes a positive. Now I see in my numerator, I do have like bases that I can simplify. So my numerator, my 9 to the 4th is going to stay up there, times, I'm multiplying, so I add my exponents, keep my base of 5, 2 plus 6 is 8, all divided by 9 to the 6th. Now I do have like bases when I'm dividing with my base of 9, so I can subtract 4 minus 6, careful, 4 minus 6 is negative 2. So it's going to be 9 to the negative 2nd times 5 to the 8th. And while this is correct, it's not fully written in the correct form because a negative exponent, to make it to a positive, again, I need to move it down to the denominator. So 5 to the 8th is going to stay here. We're going to put 9 to the now positive 2nd. We're going to move it into the denominator. So this is my final simplified answer.